Okay, so these are your worked solutions for drawing straight line graphs, positives only, so lesson 1. So you've got your table. We're going to substitute our first x value into our equation. So we've got 2 times 1 minus 1. So 2 times 1 minus 1, 2 times 2 is 2, minus 1 is 1. Then we're going to do our next x value. So we've got 2 times 2 minus 1 this time. So 2 times 2 is 4. And then take away the 1, leaves us with 3. Then we're going to do the next x value. So 2 times 3 minus 1. 2 times 3 is 6. Take away 1 is 5. And then we're going to do our last x value, so the 4. So 2 times 4 minus 1. 2 times 4 is 8. Take away 1 is 7. So now that has generated us our coordinates. So we've got 1, 1. When x is 2, y is 3. When x is 3, y is 5. And when x is 4, y is 7. And we can now plot those coordinates on our grid. So we've got 1, 4. 2, no, 1, 1. Sorry, 1, 1. 2, 3. 3, 5. And 4, 7. So ignore that one at the start, sorry, that was my fault. And then those points we can join with our ruler to make a nice straight line. And we can label that y equals 2x minus 1. So that's what your graph should look like. Okay, question 2. So we'll start with our table and substitute it into our equation. So we've got 4 times 1 minus 3. 4 times 1 is 4. Take away 3 is 1. 4 times 2 minus 3. 4 times 2 is 8. Take away 3 is 5. Then we've got 4 times 3 minus 3. 4 times 3 is 12. Take away 3 is 9. And then we've got 4 times 4 minus 3. So 16. Take away 3, which is 13. So we're not quite going to be able to plot that last one on the graph, but we can still draw our straight line. So if we go to our axes, so we've got our coordinates now. We've got 1, 1, 2, 5, 3, 9, and 4, 13. So that's what we're plotting. So we've got when x is 1, y is 1. When x is 2, y is 5. When x is 3, y is 9. And when x is 4, y is 13. Of course, we can't plot that one, so we're just going to join up the ones that we have. And remember, we're going right to the edges of our axes. The graph doesn't stop where the points stop. It continues infinitely. So that's what your graph should look like for question 2. Okay, question 3. So we've got x plus 2 this time. So we're going to take our first x value of 0. So we've got x is 0 plus 2. That's just going to leave us with 2. X is 1. So we've got 1 plus 2. which is 3. X is 2, so we've got 2 plus 2, which is 4. And if x is 3, 3 plus 2, which is 5. So that's generated our coordinates. So we've got 0, 2. When x is 1, y is 3. When x is 2, y is 4. And when x is 3, y is 5. So we're now going to plot those on our axes. So we've got 0, 2, 1, 3, 2, 4, and 3, 5. 3, 5. And again, we're going to join those up with our nice straight line going right to the edges of our axes. So there's y equals x plus 2. Question 4. So you'll notice the 2 and the plus 2x are the other way around to how we'd usually expect them, but we're going to deal with it exactly the same. We're still just going to substitute our x values into our equation. So we're going to have 2 plus 2 times 0. 2 times 0 is 0. 2 plus 0 is 2. Next one, we're going to have 2 plus 2 times 1. 2 times 1 is 2, plus 2 is 4. 2 plus 2 times 2. 2 times 2 is 4, plus 2 is 6. And the last one, we've got 2 plus 2 times 3, which is 6, plus 2, which is 8. So that gives us our coordinates 0, 2, 1, 4, 2, 6, and 2, 8, which we are now going to plot on our axes. So 0, 2, 1, 4, 2, 6, and 3, 8. And we're going to join all of those up with our ruler, going right to the edge of our axes again. And last question, question 5. So starting with our grid again, we've got 14 minus 3 times 1. So 3 times 1 is 3, 14, take away 3, leaves us with 11. 14 minus 3 times 2. So 3 times 2 is 6, 14 take away 6, leaves us with 8. Then we've got 14 minus 3 times 3, which is 9. So 14 take away 9 gives us 5. And last one, we've got 14 minus 3 times 4. 3 times 4 is 12. 14 take away 12 leaves us with 2. So again, that generates your coordinates. So we've got 1, 11, 2, 8, 3, 5, 4, 2. And we'll plot those on our axes again. So 1, 11 is up here. 2, 8, 3, 5, and 4, 2. Join those up with our nice straight line. Right to the edge of our axes again.